Hey guys, welcome to what you need to know for the tomorrow's physics test. So basically, I'm just gonna cover basically everything you need to know for tomorrow's topic test for mechanics. Okay. Alright, so we'll start with momentum. Okay, so we'll say. Okay, what you need to know, okay? So the basics, the first thing you need to know, okay, is the conservation of momentum, okay? So we can say Okay, so we need to know the conservation of momentum, okay? So what is the conservation of momentum? The conservation of momentum is assuming that all the momentum before a collision is equal to all the momentum after a collision, making the assumption that there are no external forces acting during the collision, okay? So that's basically the conservation of momentum, okay? And you need to know that for tomorrow's test, okay? Alright, so the next thing you need to know is during a calculation question, so during calculations for moment collisions, we assume so basically during the calculations we assume initial momentum is equal to the final momentum, okay? So we assume initial P is equal to final P, okay? Alright, so basically you also need to know that the impulse equation, okay? So that's F equals to, no, not F equals to, change in P equals to F times change in time. Okay, so in the exam, okay, they're probably gonna ask you this similar question. Like, for example, they're gonna ask you how are we gonna decrease the force experienced by someone in terms of safety, or how are we gonna increase the force acting, for example, when we play sport. So for example, I'm kicking a soccer ball, so how am I going to increase the force, maximum force, so that I have a high chance of scoring a goal, okay? Or the question's gonna ask you, how are they gonna make something more safe by decreasing the force experience so that the person is less likely to die, okay? So for most of these questions, you have to relate back to the stopping time, okay? So most of the time you have to relate back to the change in time. And you're relating back to the change in time, okay? And you're relating how the change of time affects the force experience given that change of P is the same, okay? So in most of these questions, they're gonna let you assume that the change in momentum is the same. So change in momentum is the same. So because change in momentum we assume is the same, so therefore if the change in time increases, then the force will decrease. But if the change in time decreases, then the force will increase, okay? So just remember that, okay? So I'm just going to give you an example, okay? So like, for example, a safety net, okay? So let's say a skydiver is diving from a plane, okay? It's going to land on the safety net, and the safety net is going to extend downwards, okay? By extending downwards, it's increasing the stopping time, okay? And then you're going to say that the skydiver it experiences the same change in momentum with or without the safety net, okay? So if I take the safety net away, he's still going to experience the same change in momentum, okay? So the change in momentum is the same, but with the safety net, we have increased the stopping time, so therefore the force experienced by the skydiver will decrease, okay? So basically that's the type of question you have to, they're probably going to ask you, okay? For theory, okay? So for a more calculation-based question, okay, there's normally three situations, okay. It's gonna be one object is moving and another one is stationary, and then the moving object collides into the stationary object, and then they move separately, okay. So they're gonna give you the speed of probably the first or the second object, and they want to find the speed of the second object, okay. So they're probably gonna say one moving object, sorry. one moving object collides with a stationary object, and they move separately. Okay? So in most of these questions, they're probably going to give you the mass of the two objects, and they're going to give you the initial momentum, and they're trying to let you, they don't tell you the speed of one of the objects after they collide, and they're going to try to ask you what is the speed after, okay? So basically, in these type of questions, okay, so you have the mass of the moving object, we'll call that m1, so mass of the moving object multiplied by the velocity of the moving object, okay, plus 0, okay, because the other, so basically we're just not gonna say plus, we're gonna say plus, so m1, not m1, what am I saying, m2, so mass of the second object, which is stationary, times by 0, okay, so that's gonna equal to the initial momentum, okay. Okay, so they're gonna, so then they're gonna tell you, for example, this, and after the collision, for example, the one object is moving at a new speed, and they're gonna try to find other object speed. Okay, so basically we can say it's gonna be momentum of the first the momentum of the first the mass of the first object multiplied by let's just say an unknown velocity, so we say this is v2 plus mass of object 2 times for example, they're going to tell you the speed. So you have to know at least one of the speeds after, okay? So so just to say this is v, let's just say we know this. Let's just say they tell you that's it's a known velocity, okay? So so it's going to be, we'll just say it's v3, okay? And that equals to m1 times v1, okay? Okay, so this might be a bit confusing at first, okay? But I'm going to give you an example, okay? So let's say a ball here is moving at 5 meters per second, and the mass is 0.5 kgs, and this ball is let's say it's 0.75 kg. Well, no, we're gonna make the numbers easier. So we'll just say this is 1 kg, and it's not moving. It's 0 meters per second. Okay. And then after they collide, okay. So after this ball is going to be, for example, let's say this ball is now moving at only 2.8 meters per second. The ball is still 0.5 kilograms, and then we'll say this is an unknown velocity, and we still know that this is 1 kilogram. Okay, so this is one example of the type of question they'll ask you. Okay. Okay, so for this example, okay, we're gonna substitute into this equation m1 times v1. So that's here. We'll say m1, so that's 0.5 times 5. Okay, so 0.5. Oh, what am I doing? So 0.5 times 5. Okay, and then plus mass of 2, the mass of the stationary ball. So mass of the stationary ball plus 1 times 0. Okay, and that equals to the initial momentum. Okay, and because 1 times 0 is still 0, so therefore we can just do 0.5 times 5, and that gives us 2.5 kg ms minus 1 equals to initial momentum. So now we say initial momentum is equal to final momentum. Okay. Okay, so basically now we're going to say the mass of the first object multiplied by the new velocity, so v2, which is now 2.8, is added to the mass of the second ball, which is 1 kilogram, multiplied by v3, which is an unknown velocity, okay? And that equals to the initial momentum, which is m1 times v1, okay? So now we're going to say that 2.5, okay, so 2.5 is equal to this, okay? And that equals to m1, so 0.5 times the second velocity, which is the new velocity, which is 2.8, times 2.8, and added to 1 times an unknown velocity, okay? So now we're going to simplify this. We're going to say 2.5 is equal to 1.4 plus 1v. Okay, we're going to move the 1.4 to the other side. So we're going to say 1.1 equals to 1v, and now we move the 1 to the other side, so therefore v equals to 1.1 meters per second, okay? So in that, we found the velocity of the second ball, okay? Okay, so that's one example of a type of question that will give you, okay? Another type of question that might give you is when they both balls join together, okay? So for example, there's one object is moving, okay, and then another object could be stationary, so it's not moving. So just say this is 0, and then it's stationary, okay, and then after the two balls will join together and they'll start moving in a certain direction, okay, and they want you to find what this v is, okay. So basically, okay, let's just call this speed is v1, okay, the mass is m1, okay, so the velocity of this is just 0, okay, let's say this is 0, and this is m2, okay, and we'll call the combined, okay, this is two balls combined, so this is m1 plus m2, and then we have an unknown velocity, okay, we'll just say this is v2. Okay, so how are we gonna find out, okay, what the unknown velocity after, okay? So basically v1, okay, times m1, okay, that equals to the initial momentum, okay, so v1 times m1, okay, because 0 times anything is still 0, so therefore this is equal to, this is 0 kg ms minus 1, okay, so that's equal to, so we have an unknown v2, so v2 multiplied by mass of the first object plus mass of the second object, okay. So this is basically how you will find out the, so now we can say that the v2, so v2 equals to v1 times m1 divided by m1 plus m2. Okay, so basically this would be how you would figure out the velocity of the both balls combined, okay? For example, the second object was moving as well, right? So if the second object was also moving, you'd basically just add whatever this momentum is, and then you'll just do the exact same thing, but adding the momentum of the second ball, okay? Is there another example? Okay, so another example will probably just be there's a ball. So I'm running out of space. Okay, so third example. So there's a ball. Okay, it's moving, and there's another ball. It's also moving. Okay, and then after they collide. Okay, so after the two balls, they're separate. Okay, so there's one moving this way and the other is moving this way. Okay, so they'll give you one of these velocities of v1, v2. Oh no, well. So say this is v1, v2, v3, v4. Okay, and this is m1, m2. Okay. So basically, how would you approach this question, okay? So basically, you got to find out the initial momentum of the system, okay? So that's v1, okay, multiplied by m1, plus v2 multiplied by m2, okay? So v1 times m1 multiplied by v2 plus m2, okay? Oh, no, plus, what am I doing? v2 times m2. Okay, and that equals initial momentum equal to final momentum. So therefore, this equals to v1, not v. Why am I keep doing this? Sorry, and that equals to v3 times m1, and I'm running out of space. 3 plus v4 times m2. Okay, so normally in this question they'll normally give you v1 and v2, and well, it doesn't really matter what they give you, okay? Actually, it doesn't really matter what they give you as long as you have 3 known values and 1 unknown, okay? Also, basically, if you know m1, m2, v1, v2, and they tell you v3, then you'll be able to work out v4. So basically, if you have one unknown value, okay? So basically, if you have one unknown value, you'll be able to find out what that unknown value is, okay? So we can just say, for this question, for example, we're trying to work out what v3 is. We don't know what v3 is, okay? So in terms of rearranging this in terms of v3, so this would be v1 times m1, v2 times m2, and that minus v4 times m2 equals to v3 times m1. So therefore, if you want to find v3, then it'll be v1 times m1, v2 times m2 minus v4 times m2 divided by m1. Okay, and that should give you v3. And it's the same thing for if you want to find out the v4. If you want to find out v4, then it's the same thing, but moving the v3 to the other side. Okay, so it'll be the exact same thing basically, and you'll divide by m2. Okay, so that's basically the calculation side of the questions. Okay, I don't think there'll be anything much more than asking you to find collision. Let me just double check. Yeah, I don't think there's much more to momentum. It's not the hardest topic, I don't think so. What the other questions are basically, they'll probably ask you to something involved with the impulse equation. So change of p equals to f, change in time. Okay, so for example, they're going to tell you that the change in p, they're going to tell you the change of p, and they're going to tell you the change in time, and they want you to find the force. Okay, so for example, an example question might be Sam is moving at 7 meters per second and reduces to 3 meters per second in 2 seconds. Sam is 65 kilograms. Okay, basically they tell you the change in p and they tell you the change in time. Okay, and they want you to find the force. So force, you don't know. So basically for these types of questions, okay, Sam was initially moving at 7 meters per second, and now it's reduced down to 3 meters per second. Okay, so the change in velocity is 4 meters per second, and change in p equals to mass times change in velocity. Okay, so therefore change in p equals to 65 times 4, and that gives us 260. Okay, so 260 is equal to f, change in time. We know change in time is 2 seconds, so 260 equals to f 2. Okay, so therefore f equals to 130 newtons. Okay, so basically this would be another type of question that they probably will give you in the exam. Okay, a similar type of question. So it's probably like similar question will maybe be they tell you the force, they tell you the time, and they want you to find the change in p, or maybe they'll tell you the change in p, and they'll tell you the force, and they want you to find the time. That's also a possibility. Okay. Yeah, I don't think there's much more in terms of momentum. Just need to double check. I don't want to miss anything out, actually. yeah, I think that's basically it for momentum as a topic. I think there's too much more to it, so I'll move on to projectile. I'll move on. Yeah, I'll do projectile motion next. Okay. Projectile motion is more calculation based. It's a more calculation based topic. Okay. Oh, sorry about that. Oh, that's annoying. That's very annoying. It's very, very annoying. So now I'll probably move on to projectile motion. So what do you need for projectile motion? Okay. So basically, what you need to this is actually a very big topic. So you actually need to know quite a lot. Okay. So let's just go through the basics first. Okay. So projectile motion, you need to know. You need to know how to find vertical and horizontal component given the initial v and an angle. So basically what I mean by this, okay, so the exam's gonna, I'm almost certain, okay, almost 100% the exam will give you, for example, there's a velocity, okay, and then this makes, for example, 30 degrees, and the velocity is 28 meters per second. I mean, this is just an example, okay, it's just an example. And then it wants you to find the horizontal component, and it wants you to find the vertical component, okay? So for this questions, you'll basically just use your Pythagoras theorem, okay? So hopefully you're all familiar with the Pythagoras theorem, okay? So that's basically SOHCAHTOA. So you can use SOHCAHTOA to find the vertical velocity and horizontal velocity, okay? So another thing you need to be very familiar with in projectile motion is your kinematic equation. So that's Vf equals to Vi plus At, okay? You're also Vf squared equals to Vi squared plus 2Ad. Vi plus Vf divided by 2 multiplied by time equals to D. Okay, that's OCD. I'll write it the other way around. So D equals to Vi plus Vf divided by 2 multiplied by time. And what you also need, you'll need to know D equals to initial velocity multiplied by time. Wait, no, that's right. Sorry, I'm having a mind blank. Let me just double check this formula. Level 2 physics. It's okay, you'll be given the formulas in the exam, okay? So don't worry about that. Yeah, D equals to VIT plus half AT squared. Okay, so you need to be very familiar with these four equations, okay? Okay, so I'm going to go through each of these equations, okay? So for this first equation, okay, distance is missing. For the second equation, t is missing. For the third equation, acceleration missing. And for this last equation, Vf is missing. Okay, so basically, if a question asks you to find a distance, for example, you won't use the first equation. So for example, a question asks you to find a certain distance, okay? So you know that you have to use a formula that has distance in the formula. So for example, you won't use the first equation. You won't use Vf equals to Vi plus At because there's no distance, okay? So basically, to be able to work out, okay, something, you need to know 3 variables out of the 4, okay? So what I mean by variables, so for example, distance is a variable, Vi is a variable, T is a variable, and A is a variable, okay? So you need to know 3 out of 4 to find the 4th, okay? So you need to know at least 3 out of 4 of the variables to be able to find the 4th one, okay? So hopefully you understand what I mean by that, okay? I'm not gonna spend too much time, okay? Because I don't want this video to get too long. Okay, so for projectile motion, you're also looking at the theory, a little bit of theory part. I'll go over the big calculation part momentarily, but I want to go through the theory part a bit more first. So theory part, what I mean is vertical V and horizontal V at horizontal V at different points. What I mean by that, okay? So for example, the question's gonna ask you, what is the vertical V and horizontal V at the midpoint, okay? So this is a very common question, okay, this one. Very, very common, okay? I see it like a lot, okay? It's very likely to be, I'm not saying it will be on the test, but I'm saying it's very likely to be on the test, okay? So basically these types of questions, okay? So I'm just going to run through it real quick, okay? So vertical velocity, okay? At a midpoint, okay, the vertical velocity is 0, okay? And that's because gravity is acting downwards, okay? The horizontal velocity is always constant, okay? So the horizontal velocity will be the same as what it started with, okay? So whatever the horizontal velocity was initially, it will be the same as the horizontal velocity at the midpoint, okay? Because there are no horizontal forces acting, okay? That's basically that question. Another question that might ask you for projectile motion might be, there's quite a lot. So they might tell you to draw vector diagrams, okay, at different points, okay? So just remember while the ball is moving upwards, right? So at the very start, there's a very high vertical velocity and the horizontal velocity is constant, okay? So anywhere on the parabola path, okay, the horizontal velocity is going to be the same length. So your vector arrow should be the same length, okay? But for the vertical velocity, okay, for example, they give you like a parabola, they give you the parabola motion, okay, so this is point A, point B, point C, point D, point E, point F, and point G, okay? So I want you to draw what the vertical velocity is, what the horizontal velocity is at each of these points, okay? So at point A, the vertical velocity is going to be the highest, okay? So it's going to be the longest acting upwards, okay? Then B, the vertical velocity is going to start decreasing, okay? It's going to keep going down. And then at D, it will be 0 because it's the midpoint, okay? And at E, okay, it will be going down. And it's going to be going down at the same length as C, okay? So we assume the parabola is symmetrical, okay? So assume this is symmetrical, okay? So therefore, E is going to be going down the same amount that C was going up, okay? And F will be going down the same amount as B going up, okay? So B, the vertical velocity is acting up, and F is going down, but they're going at the F is going down at the same amount that B is going up, okay? And at G, okay, the vertical velocity should be the same amount of what it was initially, but acting downwards, okay? And the horizontal velocity is just constant, okay? All the way the same. So all the way the same, it's just going to be this exact same length, okay? So that's a possible question to ask you. Another theory question that I might ask you. Sorry guys, I'm being really slow. So another question that might tell you to explain the effect of the forces acting on the ball. So what that means is so basically they want you to say that the horizontal component is always constant because there are no horizontal forces acting, and they want you to mention that the vertical velocity is decreasing, and eventually at the midpoint it'll be 0, and then it'll start increasing downwards, and this is because gravity acts downwards, okay? Yeah, I don't think there's too much more theory questions. I think projectile motion is more mainly based on a lot of calculation questions. Okay, so I'm gonna move on to more calculations. Okay, so basically the four key calculations you need to know. Okay, so basically time to max height. Okay. So therefore, in this type of question, so the question is gonna ask you how long will it take for the ball to reach the maximum height? Okay. So basically, again, they're gonna give you the vector diagram. Okay. So using SOHCAHTOA, you will find the vertical velocity. Okay. So in this type of questions, just remember in this time to max height. So how long will it take to reach the maximum height? You'll use the final velocity equals to initial velocity plus acceleration multiplied by time. Okay, where the final velocity is always zero. Okay, final velocity is always zero. The initial velocity is the vertical velocity. So vertical velocity that you calculated using SOHCAHTOA. So that's, you can just substitute this for vertical velocity. Okay. So a vertical velocity initial, and then we're gonna say plus. Oh no, gravity. Because you know the vertical velocity is acting upwards and gravity acts in the opposite direction, so therefore it's not plus 9.8. It's minus 9.8. Okay, and then not minus 9.8 t. Okay, so now to find the maximum, to find the time, okay, so therefore all you have to do is vertical velocity, initial vertical velocity, divided by 9.8 will give you the time. That's all. That's basically all there is to the question. Okay. So another question I might ask you to so how long how far vertically does the ball travel? How far upwards does the ball travel when it reaches? So what's the maximum height of the ball, basically? That's what I'm trying to say. What is the maximum height of the